Daniel Argante. I teach AP chemistry at Bob
Should I move
Jones, right up the road. Driving over here this morning, it's a little bit rainy, blah, blah, blah. My windshield wiper just comes right off, right as I'm about to cross the causeway, come over the bridge. I'm like, well, this is not a good sign. So hopefully my day will go better than this and the fire and everything else. So this is my 25th year teaching. After the end of my first year, they asked me to teach AP biology. Y'all may or may not know what a teacher's life is like. But for the first 3 years, you do everything you can to keep your job. So when they asked me to teach AP biology, I was like, yes. And I taught that for 12 years. And this is my 12th year then teaching AP chemistry. In the middle of the 90s, or towards the late 90s, I decided, let's throw caution to the wind and put in my name to be an AP reader. And then in 2003, I got picked to do that. That means I've been reading the AP exam for 14 years. Which means I show up in June to some city where they have 180 to 220,000 students' essays that they've written for the AP biology exam. And we sit from 8 to 5 every day doing nothing but grading papers. I know y'all are like, that's my personal hell. And the two teachers are probably like, no. But it's actually, you learn a lot. What does that mean? It means I know a whole lot more about AP than you do. So to start you off, how many times have you passed the AP Chem exam? 0. 0? What about you? None. I am the boat driver. I am the cruise ship captain. I have been to AP land. I know what's on the exam. I know what ain't on the AP exam. You have never been there. Your job is to sit back and enjoy the ride. Let me worry about who, what, when, where, and how, because we're going to try and give you the information, the tricks, the things to make you do well on the AP exam. Everybody good with that? All right, let me close the door here because they're noisy next door.
How am I going to do that?
Okay. All right, here we go. And now obviously if y'all have questions, go ahead and ask them along the way. So everybody brought a pencil or something to write with? All right, let's break it out. Here we go.
Bring some? Okay.
This is better when it was in color, so I'm not real sure why it's not. This it looks more like something scary. But, so, not real sure what's going on. I had a student in my room this week. He's a senior, and he had chemistry 2 years ago. And he's like, what are you studying right now? I said, oh, we're doing stoichiometry in my pre-AP class. And he was like, oh, I miss stoichiometry. It was my favorite. I was like, okay. I mean, it's not bad, but not something I do on a Friday night to unwind or something. Let's work some stoichiometry. So let's kind of look at what you guys have along the way. So, empirical formulas. If y'all had to find an empirical formula, when's the last time y'all did that? Pre-AP this year, last week? This year? Cool. All right. So two things. They're either going to give you percents or they're going to give you grams. And you're just going to change grams to moles or percent to grams to moles. Then you're going to divide through by the smallest number of moles. And that should give you a whole number ratio. Sometimes you got to fix it. If it's a 1 to 2.5 ratio, you got to worry about fixing that. Did that seem like a big thing? Doesn't seem like a big thing. Every question on the AP exam is designed to, are you a 1 student or a 2 student? Or, are you a 2 or a 3 student? Or, are you a 3 or a 4? Or are you a 4 or 5? If you can't do empirical formula, and you sat through a year of chemistry and a year of AP chemistry, you're either a bad student or you had a bad teacher. But they're going to ask those super simple questions for one reason. Are you a 1 or are you a 2? Now the good news is, y'all are all sharp and you know how to find empirical formula. That's low-hanging fruit. You solve that problem and you go on. Harder stuff will also be on there, the 4 or a 5. But for the stoichiometry of empirical formulas, it's crazy simple. So you would change grams to moles, divide through by the smallest number, and poof, you get an answer. 9 times out of 10, it's going to be on a multiple choice. 9 times out of 10, it's going to be a problem that you can do the math in your head. because you don't get a calculator on the multiple choice. So, if you're attached to your calculator, if you crave your calculator anytime a math question comes up, if you're addicted to your calculator, now is the time to break that cycle of addiction and get used to doing some math in your head. Okay? 3 plus 7. Alright. Dilution questions. Y'all have done dilutions along the way? Okay? So,
He's saying you should ask.
MCVC equals MDVD. You know the molarity of the concentrated, you know the molarity of the dilute, you know the volume of the dilute. They just want you to find the volume. Y'all don't find it in the packet. We're just talking. We're just talking. Okay? So you should have done a dilution calculation at some point in chemistry. Is that true?
Yes, in BS law not too long ago.
Okay. And we probably did, they probably saw in last year in chemistry a dilution somewhere. Just nod your head, sure. Okay. But the idea here is, can you do a dilution? That's also a type 1 and type 2. Are you a 1 or 2 on the AP exam? Okay? So if you guys can turn and talk real quick, those two questions that are there on that page 5, what if a volume of CO2 was given in a problem instead of mass? So if you guys could turn and talk to each other and kind of talk over those answers to 1 and 2 for me.
Is there anyone that didn't get a packet?
Alright, bring it back. So what would happen if you were given a volume of carbon dioxide instead of a grams of carbon dioxide? How would you go, somebody? Yeah.
You have to divide by the area, wouldn't you, to get the mass?
See, now you're thinking all like you're a geometry. That's not, you're given a volume, you're given liters of carbon dioxide. Yes, sir?
Wouldn't 1 mole equal 22.4 liters?
At standard conditions, you're right, 1 mole is 22.4 liters. But what if it's not what if it's not 0 degrees and 1 atmosphere? You got a gas law that ties it all together.
Boyle's law.
Boy. No. All right. PV equals nRT, the thing that ties together the pressure and the temperature, the moles, and the volume. PV equals nRT. We call that in my school perv nerd. So if you're a perv nerd, then you understand gas laws. Right? What would you, what if they included a third element? What if not just 2 elements, what if they included a third element? What would you need to know in order to determine the moles of that element?
Volume.
Well, let's say it was a solid. Let's say it wasn't even a gas.
You didn't know what it is.
You might have to know what it is, okay. What else might you have to know?
Molar weight.
The molar mass, and you can find that on the periodic table. So let me give you an instance of this. So you got 3 elements. The first one is 20%. The second one is 40%. The third element is find the thing. They just didn't give you a percentage. But you can find the percentage. Or they tell you the whole mass is 7 grams. The first thing was 6 grams. The second thing was 0.5 grams. Then you can just calculate how much that third thing weighs. They're not telling you, but they're giving you enough information. Right? So, dilution calculations are pretty easy. The big thing to watch here is, what if you mix 100 milliliters of a solution and 100 milliliters of water? What is your new volume? 200 milliliters. because you added 100 and 100. So you just got to remember that the volume that you're doing of things is the combined volume. Y'all give me that sleepy look. Titration calculations. Did y'all do a titration in regular chemistry? Like pre-AP last year, things like that. All right. Did you do anything with an indicator? No? Okay. So I'm going to leave this. If you haven't, I'm going to leave this for your teachers to talk about. But the idea is when you have an acid and you don't know what its strength is, what its molarity, you can add base to it and you can use an indicator and it turns pink. Ping! And you're like, aha! I've gotten rid of all the acid. It's a way of calculating the molarity of an unknown acid. And again, what would you have to know? You'd have to know the volume of the acid that you started with. You'd have to know the molarity of the base that you're dropping into it. And you'd have to know the volume of the base that you added to it to get it to turn pink. And you'll notice it looks an awful lot like this calculation. It's the same equation. Okay, just a set of ratios. All right. Can anybody give me the molecular formula for glucose? Biology should have burned this into your head. What is the molecular formula for glucose? C6H12O6. That's a molecular formula. What is the empirical formula of that? C6H12O6. So you're close. C.
H2C.
Okay. The thing you're missing is you said CH2C and be CH2O.
Oh.
You just brought the C around again because you didn't get enough of it the first time. Right? And so we call anything that is CH2O a carbohydrate. Carbon and water. So the difference between a molecular formula and an empirical formula is a molecular formula is just some whole number multiple. So if the empirical formula is CH4N, then the molecular formula is going to be C2H8N2 or C3H12N3 or C4H16N4. It's going to be some whole number multiple of that. And to find that, it's a Gazinta problem. So how much does, y'all should know this by now if you're good chemists. What does carbon weigh about? 12, right? Close enough to it. And 4 H's? Okay, 4. Just call it 4. All right, so now we're up to what, 16? And nitrogen, see how big you are? 14, nice. Okay, so that's a total of, what? 30. So it becomes a Gazinta problem. The empirical formula here, CH4N, it weighs 30. How many times does 30 go into 60? Twice. Which means you're going to make this C2H8 and 2. That's low-hanging fruit. That's a, do I make a 1 or a 2 on the AP exam? So far so good? All right, welcome to Malaysia. All right, if y'all will turn and talk to each other, try to figure out what goes in this blank, what goes in this blank, and what goes in this blank. What formula or equation would you use to go from grams to moles, to go from liters of gas to moles? Hint, I already told you. And what formula would you use to go from liters of solutions to moles? Go ahead and turn and talk. There ought to be 3 things that you label, fill in those boxes. Go ahead and turn and talk to each other. But 2, 50% of the right.
So it would be this.
They're just parity gases. We don't know. What's the right, yes, exactly right. I saw one mold that we used last year. They used textures, mini marshmallows, and chocolate chips. All right, here we go. What y'all get for this first spot right here? What do you use to convert granules to moles? You use the periodic table, right? The molar mass. You use the periodic table, the molar mass, because you know that 1 mole of something weighs that many grams. Now I understand when you were first in chemistry and somebody was trying to teach you about moles and how to convert, it felt painful. And nowadays you could probably convert to moles in your sleep, right? So, all right, what did y'all get for this one? Liters of gas. What equation do we use to go from liters of gas to moles? PV equals nRT. Now, y'all calling 22.4, and that's fine. But can y'all look back to the beginning of your packet real quick? There's this equation sheet that y'all have, right? This one right here?
Oh, yeah.
Right? This is your whoopee that you will carry around with you all the time. Now, can y'all find where it says 22.4?
Nowhere.
Nowhere. So that'd be something you have to memorize. Can y'all find where it says PV equals nRT? Very top. And what part of the sheet would you look at if you were talking about gases, liquids, and solutions? Gases, liquids, and solutions. Right? So, the 22.4 doesn't work all the time. I love it when y'all try to use 22.4 all the time. You got 1 liter of solution, this aqueous solution, 22.4! That's a gas at 0 degrees, at 1 atmosphere. Now, have y'all done thermo as well? Y'all done a little bit of thermo? Okay. What are standard conditions for thermo? What's the standard temperature? 25 degrees. What's the standard temperature for gases? 0. Makes it a little bit difficult, right? So I would work with PV equals nRT here, just so that you know, without a doubt, PV equals nRT, you can go from liters of something to moles of something. And then, lastly, liters of solution. What do y'all know about liters of solution? How do we measure concentration? That's a good question. Molarity. What is molarity equal to? Moles of solute per liter of solution. So we're using molarity is equal to moles per liter. And if you have, I know that's kind of hard to see, so this one right here is fine, that's better. If y'all have not seen this notation before, MOL, liters to the -1 power, people are lazy. I'm lazy, AP is lazy. Have you ever tried to type a fraction before? Not fun. How do we get away from that? We make it liters to the -1 power, which is the same thing as put the liters on the bottom. So when you see that, be like, I don't even know what's going on. Moles times liters to the -1 moles per liter. Right? All right. Y'all turn and talk with each other. Try to figure out the ratio. If I start with 0.1 moles of this, figure out the question marks. Start with 0.5 moles, figure out the question marks. See if y'all can fill in this whole table. You've got 1.2 minutes. filling in that table right there at the bottom of Malaysia. Turn and talk with each other. No calculators, by the way.
I'm going to live here and say I already see batteries.
You've got the balanced equation up top. You're given one type of moles, you ought to be able to populate all the rest of them. Y'all are staring at it like you don't know what's going on. So let me walk you through. I know some of y'all know what you're doing, but what's the ratio of C3H8 to O2? 1 to 5. So if I start with 0.1 moles of that, how much oxygen will it take? 0.5. 5 times as much. And if you don't remember your dimensional analysis, because you're sleepy this morning, it would look something like 0.1 moles of C3H8. That's close enough. That there's 5 moles of O2 for every 1 mole of C3H8. So that answer should be 0.5. See where I'm headed? All right, take the rest of your 1.2 minutes and figure out those other numbers in the blanks, please. Learn to talk to each other. You can't help each other on the AP exam, but you can help each other today. You already know. Okay. Oh, okay, all right, okay. Okay, that's why. Yeah, okay. I'm sorry. It was late. I was like this.
You multiply these by 5 and you divide this by 5.
All right, that's what you should have got for the first one.
Same way. Every one of the first one, there's 5. The second one, there's 3. The third one, there's 4.
Now I know what y'all are thinking. Y'all are thinking, yeah, but this is easy. AP chemistry is hard. Do you think I would be up here trying to talk to y'all about stuff that's not on the AP exam? No. What's my job? I'm the boat captain. I have been there. You're on the cruise ship. I know where to stop. I know the best spots to see the whale. I know where all the low-hanging fruit is. This right here, ladies and gentlemen, is places to grab points left and right. So, first one looked like that. Second one looked like that. Y'all agreeing with these numbers so far?
Yeah.
Third one? And the fourth one. You're still looking at those ratios. For every 2 of these, you use 5 times fewer. So 2 divided by 5 is 0.4. For every 5 of these, you only make 3 of those. So it's a 3/5 ratio. 3/5 of 2 is 1.2. And if you start with for every 5 of these, you're going to make 4 of these, so it's a 4/5 ratio. And keep in mind this. Do y'all remember the law of conservation of energy?
Yeah.
Law of conservation of mass. Do you remember the law of conservation of moles?
No.
There is no such creature. But some people are like, well, but this is 0.6. Point 7, not possible. No law of conservation of moles. 2 arms, 2 legs, 10 fingers, a nose, 2 eyes, 2 ears. Makes 1 person, not whatever all those numbers add up to be. Right? No law of conservation of moles. Don't get yourself all tied up with like, this doesn't work. No law of conservation of numbers in a balanced equation. It's not like 1 and 2 has to be a 3. Right? All right. Multiple choice number 1. Right. How many multiple choice do you have?
3.
No, sorry. On the AP exam.
A lot.
A lot. Nice. I know it's only November, but come on. So what?
I want to say it's about 55.
About 55? Okay. Y'all would not make very good football coaches. But what's a football coach do before a big game? They watch game film to know who their opponent is. Y'all don't know who your opponent is. So on May the 7th, you'll have 60 multiple choice questions. 10 of them won't count. You don't know which 10. I don't know which 10. There's only a few people that know which 10. And the reason why they do that is they offer those same questions every year to see, is this group just as smart as the group that took it last year, is just as smart as the group that took it 2 years ago. It's called norming the test. So you've got 60 questions. How long do you got to take?
60 minutes.
60 minutes? Y'all are horrible. You're great people, but knowledge, 90 minutes. So what does that leave you per question? 60 questions, 90 minutes. A minute and a half. So, ready? Set. You can turn and talk with each other if you want to. Go.
That would be.
Are you getting called?
All right, that's 1 minute. All right, and 20 seconds, long enough. Here's the idea. A question like this, you ought to be able to do it in a minute or less. Because trust me, you will need that other 30 seconds later on. So it's not like you really get a minute and 30 per question. That's the average time, which means on some of these you need to be making it small as a time as possible. So you may want to share their answer. Oh, y'all should be quiet. What in the back? A. Why? Because you chose A. Total guess. Anybody else totally guess A?
I chose C.
You chose C because?
K2. Oh no, that's wrong. Or C's wrong. Because I looked at the molar weight on the periodic table of K, and then just took K's molar weight, subtracted it from the molar weight of the
So you
whole.
didn't think 2 of them is what you're saying?
Yeah, I didn't
Right.
think to.
So we've had A and C. Anybody else want to jump in?
It's me, isn't it?
You B. Why?
Because I did what Sawyer did, except I didn't forget that there were 2.
Okay. Nice. Wait, nice to throw shade. Nice.
Sawyer's a great guy.
I knew I got the right answer because I did not what he did.
because I did it
All right,
right.
so,
I picked B.
the basic thing here is, don't get lost in the math, especially if you're math sensitive, like, oh, math without a calculator, right? Because remember, no calculator. So the key here is, how many oxygens do all of them have? One.
Will it go to red?
That's their point of comparison. The most oxygen is going to be the one that has the least of everything else. So, you know oxygen weighs 16, right? So 62 minus 16 is going to be 46-ish, right? 40 minus 16 is going to be 24. And in a ratio of grams to grams, 46 to 16 versus 24 to 16, the answer ends up being B, because the most oxygen is the least of the other thing. Now, I will tell you that this is from an old AP exam within the last 4 years, and this was number 2 on that exam. They're slapping you in the face right up front. So let me give you the other thing. If the math scares you, there's no reason why you have to answer it then. You get to write all over the test. So it's totally okay to take this question and mark through it and say, nope, nope, and work your way towards an answer. Okay? If you can bring it to within 2, circle those 2. You can always come back to it later, but you definitely don't want to burn 5 minutes trying to be absolutely right on every question. You won't finish. So if you're in town trying to buy that necklace and you missed the boat on our cruise through AP land, you are never going to get to finish the cruise because I left you behind. So you got to answer the question, get on with it. So the answer was B. If you got that right, good job. All right. Do you see that line right there that's underneath number 1? Okay. On the AP exam, they're going to throw a line in there between question groups. In other words, that set where it says M with a +1 charge, that works for 2 and 3 because that line demarcates this text up there works for 2 and 3. So, if you guys could, go ahead and answer questions 2 and 3.